Hello and welcome to another video. In this video we're going to be working on count subislands, and in this one we're given two matrices containing zeros and ones, and an island is a group of ones that are connected. So they can be connected in any way as long as it's not diagonally, and any cells outside of the grid are considered water, so all of these cells like water and so on. And an island in grid 2 is considered a sub-island if there's an island in grid 1 that contains all the cells that make up the island in grid 2. Return the number of islands in grid 2 that are considered sub-islands. So let's break this section down. So basically what they're saying is an island here is considered a sub-island if every single cell of that island is covered by an island, one island over here. But the thing to recognize is if every single cell of an island is covered, like if all of these cells are also covered here, so that's these cells here, all of these cells will also be one island. Because you can't have two islands cover one island, right? If two islands covered one island, they would have to be connected, right? Like if on this side, if this has to be ones, you can't make these cells part of two different islands. It's impossible because they're connected. So basically, it's kind of a simpler problem where all we have to do is just traverse. Anytime we get to an island here, we just DFS every single cell on the island, and we check, is that cell also land over here? And so, for example 1, we'd say, like, is this land? Yes, 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 yes. So the whole island is land over here. That's these cells here. So this is one island. Is this cell an island? No, it's not. Or land, sorry, not an island. Is this cell land? Yes, it is. Is this cell land? Yes, it is. Are all of these land? No, they're not. So these are the only sub-islands. In the second example, same thing. So for this whole island, we would check, are all of these cells land in here? They're not, because we have these two that are not land. So this would not be a sub-island. And then for this island, are all of the cells in this island land over here? Yes, it is. Here and this as well. So there's two islands here, two sub-islands, and there's three sub-islands here. But that's kind of the basic algorithm, is traverse grid 2. So we can write it in steps. Traverse grid 2. Anytime we find land that we haven't visited, let's just DFS or BFS that whole island. And if the whole island is land in grid 1, then this is a sub-island. And you do want to traverse the whole thing and mark it visited. So for example here, like we'll be traversing, and even if we find something that's not a sub-island, we still want to keep traversing the whole thing. So we always want to traverse the whole thing, just so we don't have to like traverse again, because we only have to traverse each island once. Like imagine in the worst case this is all water. You wouldn't just like go here and say like, oh, this is water. Let's just like stop, and then let me try here. Also, it's water and stop. So you want to traverse the whole island, but you want to just keep track of a Boolean value of like, is every single path I traversed true? And if the whole thing is true, then you would say this is a sub-island. That's kind of idea. It's basically like a number of islands problem, pretty straightforward. So that's what we're going to do. You can do a DFS or you can do a BFS. I guess let's do a DFS this time. Yeah, so, okay. But that's basically all we have to do. So, okay, so let's have some class variables, like directions. And then we can go in 4 directions. So, -1, 0, or 0, 1, or 0, -1. And this is this. And then we want to have rows. We want to have columns. And then we want to make a copy of grid 2. That way, instead of having like a visited set or something, the easiest thing to do, because I'm not exactly sure what we'd want to mark for visited. I think it depends. So instead, let's just make a copy of grid 2. And then anytime we visit a cell, we can just turn it from a 1 to a 0, so we don't have to visit it again, I think is what we're going to do. So we're going to say like visited will just be a copy of grid 2. Yeah. And then let's initialize everything here. So rows equals grid 1 length, calls equals grid 1 0 length. And we want to make a copy of grid 2. So we can just say like visited equals, this is going to be rows columns, and then we can just go through the grid and copy the values. So to say like 0. And same thing for the columns. Okay, and this should be right. And then we can just say visited column equals grid 2. Alternatively, you could modify grid 2 in place. That's also fine if you want to do that. I prefer not to modify the inputs, but either one's fine. Then we have our sub islands equals 0. And then we want to loop through this thing again and basically check if we haven't visited it yet, then let's do a DFS. Yeah. So we can say if visited row column equals 1, let's do a DFS. And then a DFS will give us a Boolean value back. So we could say if, I guess we could say if this is 1, let's do if DFS, or we could combine it together, I guess. So and DFS row column, and we have to pass it grid 1. Then we will increment the sub islands. Okay. Now we just have to return here, so return sub islands, and then we have to write our DFS function. So DFS will be a Boolean. It'll take row column grid 1. Yeah. Okay. And basically, so if we're out of bounds, we can return true. If we already visited it before, then we don't want to increment the island, so we want to return false. Because like if we visited something that's already part of an island, well, actually, technically we should never hit. Yeah, so technically, if it's water, we can return actually true, I think, because technically when we traverse the grid 2, like here, like when we're gonna traverse this from here, we're gonna turn all this to 0. So this will all be 0. So we're never going to start a DFS again from any of these cells. So I don't think that's something we have to worry about. Yeah, so if it's 0, it just means we have a land that has water next to it, which is fine. Like that's allowed. So actually, so we can say if row is less than 0, or row equals rows, or column is less than 0, or column equals columns, or visited row column equals 0. Those are all fine. So if those are the case, return true. And this is just row and column. Okay, so these are all fine. Otherwise, we're gonna turn it into water because we visited it. And we're going to DFS in every direction. And as long as all of them are true, then we return true. So we can just say return. Yeah, we can say like, I guess we can probably just get rid of these directions if we want to. Yeah, and then just call DFS 4 times. So we can just say return DFS row plus 1 column, grid 1, and just 4 of these basically. So 1, 2, 3, 4. Yeah. And these, instead of commas, then you just need to be ands. So if it's all of these, then we can, yeah, so Actually, no, this is problematic. So hopefully you can understand why this is problematic, because if this is false, it's not going to execute the rest of them, so we don't want to do it that way. Yeah, so let's go back and have our directions, because yeah, this is, you still want to traverse the entire island. So let's just do it this way. So we can just say like check or something is true, and then we'll set it to false. So we could say like for int array dir in directions. What did I call this? Dirs. Okay, and this needs to be Boolean. So we still want to DFS in every direction until we actually get to these cases. But if it's false, then we make this false. So if DFS, so r plus dir 0, c plus dir 1, and grid 1. So if this is false, then we want to say check is false. So basically all of them have to be true, but we still go through the whole thing regardless. So now we just return check. All right, and that should be it, I think. Yeah, and yeah. There is one more thing actually here. So the Boolean check isn't always true. Boolean check, we actually have to check if this like cell is in grid 1, right? We haven't done that at all. So like for a cell, we have to check if it's a 1, it has to be a 1 here too. So this is going to be, we can just initialize it to grid 1 row column equals a 1. And I think that should do it. Let's see. Okay, nice. So hopefully that makes sense why we have to do all these things. So we actually have to check that our island, like our cell, is in here. Then we have to go in every direction. But even if something fails, we still want to traverse the whole thing. Like let's say we fail at this cell. We still want to traverse the rest of it and mark it all as visited so we don't have to like DFS from here again. Hopefully that makes sense. All right. So this is like nm time and nm space, I think. Let's just double check. So directions is nothing. This is all nothing. So visited is the copy of grid 2, so that's already nm or mn. And then this is mn. This is mn. And because we're not visiting the same cell multiple times, because we mark it as visited, we're only going to DFS from every cell one time. Well, we can get to some cells multiple times, but it's not going to be like quadratic or anything. If you want, you can check before DFSing, but it doesn't really matter. Because essentially, when we get to a cell we've been at before, all we do is just return. So that's fine. So yeah, this is like n by m and n by m. So you can run this thing. But I think it just copies, yeah, row column, row column. And for all these Java things, I wouldn't be super concerned about the runtime. It's more just like, which way did you do it? So it doesn't really matter, I think. Like some small optimizations, you know, would make it better. Yeah, so kind of not a super tricky problem, just to recognize, just check that this whole island is in this whole thing. And if all of these cells are basically covered by 1, then it's a sub-island, and that's all we have to do. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.